Hello, I'm Mr. Charlie and welcome back to Physics A. This is lesson 4, constant acceleration and free fall. So this is our second of a three-part series on kinematics, and kinematics being the study of motion, not what causes it, but just how the quantities of motion interact, how time, acceleration, velocity, and speed and displacement are all related. So we talked about the first two there on time, but we talked about the first two, displacement and velocity, last lesson. So today we're going to talk about the third, constant acceleration, and basically that's going to talk about how fast velocity is changing, and that's going to lead to a lot of useful applications such as free fall equations. You know, if you drop something, how fast does it fall? How fast does its velocity change? How far does it fall? If you fire a cannon, where will it land? Where is the maximum peak? How long does it take to land? All that stuff. So that's what we're going to talk about today. We're going to talk about constant acceleration today and free fall, which will lay the foundations for next lesson, which will be projectile motion and two-dimensional motion. So we will continue with our focus on 1D motion, that is motion in a line, and how objects change their velocity through acceleration. So with that being said, let's get started. So with the definition of acceleration. What is acceleration? Well, unlike speed and velocity and displacement and distance, the constant of acceleration is only described as a vector. We don't have any kind of tricky, oh, this is the average speed and this is the average acceleration, and if they're going different directions, they cancel out, and I'm doing the loop in the track. No, it's just one acceleration, and it has no real scalar application. So we always consider an acceleration. Why is that? Because, well, like acceleration is a change in position over time, like velocity is a change in position over time, acceleration is a change in velocity over time. So there's really no way to have any kind of scalar acceleration because it always has to be either with the direction of velocity or against the direction of velocity or turning or something. So it really doesn't make sense to have a scalar acceleration. It has to have a sign. If you have positive acceleration, then you're either speeding up in the direction of your velocity or slowing down in that direction, and vice versa for negative. So it works pretty much like, so the acceleration is defined mathematically like so, change in velocity over change in time, just again, very exactly analogous to how velocity was change in position over change in time, or the final velocity minus the initial velocity divided by change in time. And it works pretty much like you'd expect, just the way it's used in day-to-day speech. Car commercials might say, our car accelerates from 0 to 60 in 3 seconds, and that's supposed to be impressive because 3 seconds is a pretty low delta t, and therefore it's a pretty high a. If you could drop that to 1 second, you would increase your acceleration by a factor of 3. If this went from 3 to 1, then that number would be 3 times larger after dividing. So this is why car commercials advertise this. It's an acceleration. How fast can you get from some velocity to some other velocity? So it's always a vector. Even if speed is constant, changing the direction implies an acceleration. For example, imagine a car on the road and it's moving at a constant velocity and it enters a turn, okay? Its velocity changed from north to east, and therefore it did accelerate, even if its speed remained, 25 meters per second the whole time. Even if its speed was constant, if the velocity changed, then there was an acceleration. Now be careful. Okay, so acceleration can be positive or negative, right? Especially when we're dealing with acceleration on a line, we're going to want to keep track of whether it's positive or negative. Again, positive usually means to the right or up, and negative usually means to the down or to the left. So there's a natural tendency for us to think, okay, positive or forward acceleration means speeding up, and negative acceleration means deceleration or speeding down. Deceleration is a tricky word, and